everyone, this is Kalpana here. In this video, we are going to evaluate these two integrals. So let's get started. First one, evaluate integral sin x into square root of 1 plus cos 2x into dx. Solution. We have integral sin x into square root of 1 plus cos 2x into dx, right? Since we know that cos 2x equals to 2 cos square x minus 1 or 1 minus 2 sin square x. Let's say for both the formulas. We have cos 2x equals to 2 cos square x minus 1 and cos 2x equals to 1 minus 2 sin square x. Right? Then 1 plus cos 2x equals to 2 cos square x. Right? Then 1 minus cos 2x equals to 2 sin square x, right? Simply, if you take 1 plus cos 2x and substitute cos 2x equals to 1 minus 2 sin square x, you'll get 1 plus 1 minus 2 sin square x, which is equals to 2 minus 2 sin square x, right? If you take 2 common from these two, you'll get 2 into 1 minus sin square x. Since we know that sin square x plus cos square x equals to 1, then if you take the sin square x to RHS, you'll get cos square x equals to 1 minus sin square x. Now, you can replace 1 minus sin square x by cos square x, right? So, you'll get 2 cos square x. Okay? So, we have, therefore, cos 2x equals to, 1 plus cos 2x equals to 2 cos square x. Okay. By using first one, you'll get directly 1 plus cos 2x equals to 2 cos square x. Okay. Fine. Now, replace this 1 plus cos 2x by 2 cos square x into dx. Now, you could write this as integral sin x into square root of 2 into cos x whole square into dx. Again, you could write this as sin x into square root of 2 into square root of cos x whole square. Okay. Square root of cos x whole square can be written as, since square root of a equals to a power 1 by 2, then you could write this as cos x whole square for 1 by 2, since a power m whole power n equals to a power m into n, then you could write this as for m equals to 2 and n equals to 1 by 2. Cos x in power 2 into 1 by 2, which is equals to cos x power 2 by 2, which is equals to cos x power 1 equals to cos x. That is square root of cos x whole square or cos square x is cos x. Since square root 2 is constant, so you could write this outside the integral. You'll get square root of 2 into integral sin x into square root of cos square x, or square root of cos x whole square is cos x into dx. Okay. Now, we know that 2 sine theta into cos theta equals to sine 2 theta, right? Then, for theta equals to x, we'll have 2 sine x into cos x equals to sine 2x. In order to use this formula, you need some 2 here, right? For that purpose, what we are going to do is we'll simply multiply and divide 2 to this integrand. Okay? Now we can take 1 by 2 outside the integral. We'll get root 2 by 2 into integral 2 sine x into cos x into dx. Since 2 sine x into cos x is sine 2x, in the next step you'll have square root of 2 by 2 into integral sine 2x. Okay? Since integral sine ax plus b into dx equals to minus 1 by a into cos ax plus b plus integral constant c. Then you'll get root 2 by 2 into minus 1 by, for a equals to 2 and b equals to 0, minus 1 by 2, that is 2 into cos 2x plus integral constant c. So this equals to minus square root of 2 by 2 into 2 into cos 2x plus integral constant c. You can write 2 as 2 power 1, right? And we know that 1 by 2, half plus half equals to 1. So you can replace this 1 by half plus half. You could write this as, right? Since a power m plus n can be written as a power m into a power n. Okay? So, since you know that square root of a equals to a power 1 by 2, then you could write this 2 power 1 by 2 as square root of 2. So therefore, 2 equals to square root of 2 into square root of 2, right? Now, you can replace 1, 2 by square root of 2 into square root of 2. So this equals to minus root 2 by root 2 into root 2. Then you'll just write this as it is into 2. You could write this as root 2 into root 2 into 2. Better. Now you can cancel. Okay? Into cos 2x plus integral constant c. This equals to minus 1 by root 2 into 2 is 2 root 2 into cos 2x plus integral constant c. Therefore, integral sin x into square root of 1 plus cos 2x equals to minus 1 by 2 root 2 into cos 2x plus integral constant c. Now coming to the second problem. Evaluate integral 1 by 1 minus sine x by 2 into dx. Solution. We have integral 1 by 1 minus sine x by 2 into dx. Now we are going to rationalize the denominator. 1 plus sine x by 2 by 1 plus sine x by 2 into dx is equals to 1 plus sine x by 2 by 1 minus sine x by 2 into 1 plus sine x by 2 into dx. So this is equals to integral 1 plus sine x by 2 by this of form a minus b into a plus b, which is equals to a square minus b square. So you could write this as 1 square minus sine square x by 2, right? Since we know that sine square theta plus cos square theta equals to 1, then cos square theta, you could write this 1 as 1 square, or you can write this 1 square as 1, okay? If you take this sine square theta to right hand side, you'll get 1 square minus sine square theta, right? For theta equals to x by 2, you'll get cos square x by 2 equals to 1, or 1 square minus sine square x by 2. So now you can replace this 1 minus sine square x by 2 by cos square x by 2, okay? So this is equals to integral 1 plus sine x by 2 by replace 1 square or 1, okay? 1 square minus sine square x by 2 by cos square x by 2 into dx. Since we are having two terms in the numerator and one term in the denominator, the total fraction can be separated, or we can write this fraction into two fractions. This is equals to integral 1 by cos square x by 2 plus sin x by 2 by cos square x by 2 into dx. Again, you could write this as integral 1 by cos square x by 2 plus sin x by 2 by cos x by 2 into cos x by 2 into dx. This is equals to integral 1 by cos square x by 2 plus sin x by 2, sin x by 2 by cos x by 2 into 1 by cos x by 2 into dx. Since we know that reciprocal of cos theta equals to secant theta, then if you square on both sides, you'll get 1 by cos square theta equals to secant square theta, and sin theta by cos theta equals to tan theta. Now this becomes integral 1 by cos square x by 2. Since 1 by cos square theta equals to secant square theta, then you can replace this by secant square x by 2 plus sin theta by cos theta equals to tan theta. Then you'll get tan x by 2 here into 1 by cos theta is secant theta. So we'll get secant x by 2. Okay, into dx. Right. So this equals to, since we know that integral secant square ax plus b into dx equals to 1 by a tan ax plus b plus integral constant c, and integral secant ax plus b into tan ax plus b into dx equals to 1 by a secant ax plus b plus integral constant c. Okay, so now you can apply this formula. Okay, you're going to apply this formula to the first integral and this one for the second. This equals to integral secant square ax plus b is 0 for a equals to 1 by 2, b equals to 0. Integral secant square x by 2 is equals to 1 by a. You're having quotient of x is 1 by 2 into tan x by 2 plus integral secant x, okay, integral secant ax plus b into tan ax plus b into dx is 1 by quotient of x. Quotient of x is 1 by 2, right? So you could write this as tan 1 by 2 into x plus 0 into secant 1 by 2 into x plus 0. Okay? So that you can apply this formula without any confusion. For a equals to 1 by 2, b equals to 0, for a equals to 1 by 2 and b equals to 0, we get 1 by a, that is 1 by 2, quotient of x is 1 by 2, right? 1 by 2 into secant ax plus b, that is x by 2 plus integral constant c. So this is equals to 1 by 1 by 2 is equals to 2 tan x by 2 plus 2 secant x by 2 plus integral constant c. This completes the second problem. Or you can take two constant from these two terms. You'll get 2 into tan x by 2 plus secant x by 2 plus integral constant c. So therefore, integral 1 by 1 sine x by 2 into dx equals 2. Okay. Fine. This is all for now. Hope you'll understand. We'll see you in the next video. Until then, bye bye.